Scientists recorded a sound that could be heard across half the planet, and after decades of research, they still don't know what made it. Think about that for a second. We have technology that can map the surface of Mars. We can detect a single atom. We've looked back in time billions of years using telescopes. But something in our own ocean made a noise so massive it shook recording equipment thousands of miles away, and we have no idea what it was. This is one of those things that sounds made up, like something out of a sci-fi movie, but it's real. It was recorded. Scientists studied it. Governments were notified. And the best answer anyone could come up with was basically, we don't know. So today, we're going into that story. What was the sound? Where did it come from? What do we actually know? And why, after all this time, does it still not have a solid explanation? Let's get into it. First, you need to understand something about the ocean that most people don't think about. The ocean is loud. Not in the way a city is loud, not in the way you'd hear if you jumped in at the beach. But deep underwater, sound travels differently than it does in air. Sound moves faster underwater, and it can carry incredibly far, like insanely far. There's actually a layer in the ocean called the SOFR channel, which stands for Sound Fixing and Ranging. It's basically a zone in the deep ocean where the temperature and pressure create the perfect conditions for sound to travel. Whales use it to communicate across entire ocean basins. It's like a natural highway for sound. Because of this, scientists back in the Cold War set up underwater microphones called hydrophones all across the ocean. The original reason was to track Soviet submarines. If a sub moved or if something blew up, those hydrophones would pick it up. The system was called SOSUS, Sound Surveillance System. Eventually, after the Cold War ended, those hydrophones were made available to scientists, and scientists thought, great, let's listen to what's actually happening in the deep ocean. Whales, earthquakes, underwater volcanoes, let's get a picture of what's down there. What they got was more than they bargained for. In the summer of 1997, researchers at the National Oceanic and Atmospheric Administration, NOAA, were going through recordings from their hydrophone network in the Pacific Ocean. Routine stuff. They were used to hearing whale calls, distant earthquakes, ships passing by. Normal sounds. Then they heard something that wasn't normal at all. The sound lasted about 1 minute. It was picked up by multiple hydrophone stations separated by thousands of miles, and it was loud. Not just a little loud, extremely loud. Loud enough that the sensors recording it were far apart, and all of them caught it clearly. Scientists named it the Bloop. And that name, the Bloop, sounds kind of funny, almost cute, but the actual sound is not cute. If you look it up and listen to the sped-up version, because it was recorded at a very low frequency, it sounds deep, strange, almost alive. There's something about it that feels wrong in a way that's hard to put into words. It rises, then drops, and there's this quality to it that doesn't sound like a machine. It doesn't sound like a geological event. It sounds almost biological. That last word is what sent people into a spiral. Here's the thing about biological sounds. When scientists say a sound is biological, they mean it has the characteristics of something living making it. The way the frequency moves, the way it rises and falls, the pattern of it matches what living creatures sound like when they make noise. The problem with the bloop being biological is this: whatever made it would have to be enormous. The largest animal on the planet is the blue whale. A blue whale can produce sounds that reach around 180 decibels. Blue whales are the biggest animals on Earth, up to 30 meters long, weighing up to 200 tons. They're massive. But here's the thing. Researchers who studied the bloop said whatever made it would have to be significantly louder than a blue whale, which means if it was a living creature, it would have to be much, much bigger than a blue whale. And that's where things get interesting, because the largest animal we've ever found in the ocean, living or dead, is the blue whale. There's nothing documented that's bigger. So, if the bloop came from a living creature, that creature would break every record we have. It would be something we've never seen, never found, never even found evidence of. For a lot of people, that's when the brain goes to one place: sea monsters.
Now, I want to be straight with you here, because it's easy for this to go into conspiracy theory territory, and I want to actually stick to what's real. The idea of enormous, unknown sea creatures isn't as crazy as it might sound on the surface. The ocean is genuinely, massively unexplored. Over 80% of the ocean has never been mapped or seen by humans. We're talking about an environment that covers more than 70% of the Earth's surface, with average depths of around 3,700 meters, and in some places, nearly 11,000 meters deep. We discover new species in the ocean constantly, not just small fish either. In 2013, researchers found a living specimen of the giant squid off the coast of Japan. Giant squids can reach around 13 meters in length. For a long time, we only had dead ones washed up on beaches, and some people thought they were exaggerated myths. They weren't. There are also creatures like the colossal squid, even bigger than the giant squid, that we've barely studied. We've found remains of some. We've seen one alive on camera once, just once. So the ocean does hide big things. That part is real. But here's where science pulls back. Finding a creature large enough to produce the bloop would require something that doesn't fit into any known ecosystem. An animal that big would need a massive amount of food. There would be evidence, bodies washing up, whale carcasses with unknown bite marks, something. And we don't have that. So the creature explanation, while exciting, doesn't quite hold up. For years, the bloop sat there, unexplained. It became one of those internet mysteries that people passed around, and it got more dramatic with each retelling. Forums filled with theories, everything from giant squids to undiscovered prehistoric creatures, to things even further out there like underwater alien bases. But then, in 2012, scientists at NOAA came back to the bloop with better tools and more data, and they offered a new explanation: ice. Specifically, something called ice quakes. Here's what that means. In Antarctica, massive chunks of ice break apart. When huge sections of glaciers crack and shift, or when icebergs fracture, they release enormous amounts of energy, and that energy creates sound, big sound. The argument NOAA researchers made is that the bloop matches, in terms of frequency and profile, the sounds that ice quakes produce. And when you look at where the bloop originated, it was in the southern Pacific Ocean, not far from Antarctica. When they compared the bloop to known recordings of ice-related sounds, the similarities were there. The way the sound was shaped, the frequency patterns, the general character of it, it lines up with what large ice movements can produce. So officially, the current scientific position is that the bloop was most likely caused by a massive ice quake, not a monster, not an alien, ice. Now, I want you to sit with that for a second, because there are people, including some scientists, who aren't fully satisfied with that answer. Not because they want it to be a monster, but because the data isn't a perfect match. The bloop had some characteristics that typical ice quake recordings don't fully replicate. The way it sounds isn't identical to what we'd expect from a purely geological event. And the fact that it was so loud, louder than almost anything else recorded in the ocean, raises questions about what kind of ice quake would be needed to produce it. Also, the bloop has never been recorded again. You'd think if it was a natural geological process, something like ice breaking, it would happen more than once. Ice quakes happen all the time in Antarctica.
but a sound with the exact profile of the bloop hasn't shown up in the recording since. Does that mean it wasn't an icequake? Not necessarily. It could be a very specific and unusual combination of factors that haven't repeated. Weird things happen once and don't repeat. That's not impossible. But it does leave a small gap, a little bit of uncertainty that doesn't fully go away. And that uncertainty is actually the most interesting part of this whole story, because the bloop isn't the only unexplained sound in the ocean, not even close. NOAA's hydrophone network has picked up a whole collection of strange sounds over the years, and many of them have names that scientists gave them during analysis. There's one called Julia, recorded in 1999, a long, slow sound that lasted about 15 seconds. The best explanation is a large iceberg running aground somewhere, but it was never fully confirmed. There's Train, which sounds like a very steady, consistent noise that researchers think might be related to ocean floor geological activity, but the specifics are still fuzzy. There's Whistle, which sounds almost exactly like a high-pitched whistle and was recorded once in 1997. No explanation has been confirmed for that one. And there's Upsweep, a sound that's actually still being detected today, recorded first in 1991, that consists of a seasonal, repetitive sweeping tone. It seems to originate from somewhere in the southern Pacific. Scientists think it could be related to volcanic activity on the ocean floor, but the exact source has never been located. These sounds aren't viral like the bloop, but they exist, recorded, real, sitting in the data without a fully confirmed explanation.
Why does this matter? It matters because the ocean isn't just some background thing on Earth. It covers most of the planet. It drives weather patterns. It absorbs massive amounts of heat. It's home to more species than anywhere else on Earth, and most of those species have never been seen by a human. The oceans are also absorbing the effects of climate change in ways we're still trying to understand. Glaciers are melting faster. Water temperatures are shifting. The underwater sound environment is actually changing because of increased shipping traffic and human noise. All of this affects sea life, especially animals like whales and dolphins that rely on sound to communicate, navigate, and find food. So studying underwater sound isn't just curiosity, it's actually important science. And the fact that we have unexplained recordings in the middle of all that data is a sign of how much we still have to learn. The ocean is the least explored environment on Earth. More people have walked on the moon than have been to the deepest point in the ocean, the Mariana Trench. We have better maps of the surface of Mars than of the ocean floor. Think about what that means for the things we might be missing. The bloop, in the end, probably was an icequake. The scientific consensus leans that way, and there's real evidence behind it. I'm not going to sit here and tell you there's a giant monster down there. The evidence doesn't support that. But here's what's true. The ocean is so vast and so unexplored that we genuinely cannot rule out discoveries that would completely change what we think we know. New species get found every year. Underwater geological processes are still being mapped. The deep ocean is so far from anything we'd call normal that even trained scientists are sometimes caught off guard by what turns up. The bloop is one small example of something that happened, something real, something recorded that stumped some of the best acoustic researchers in the world for years. And even now, with what we think is the answer, there are still small pieces that don't fit perfectly. That's science. That's exploration. Not everything has a clean, satisfying answer with a bow on it. Sometimes the best answer is, we think it's this, but we're not completely sure. And sometimes that small gap of uncertainty is where the most interesting questions live. We recorded a sound loud enough to cross an ocean, and we spent over a decade figuring out what it was. And even now, not everyone is fully convinced. Somewhere in the deep Pacific right now, there are sounds happening that no human has ever heard. Some of them will make it to a hydrophone, some of those will be strange enough to get a name and a file, and some of those files will sit on a server unexplained, waiting for someone to figure them out. That's the ocean. That's what's out there. If you want more videos like this, real mysteries, real science, no nonsense, subscribe so you don't miss the next one.